Good day class, welcome to our channel, Leaders Academy 5074. Today we are looking at advanced engineering mathematics, Laplace transform of elementary functions. Please, I want you to please pay close attention to this because we're going to be using some integral functions here while solving. So because of that, we are not going to finish this topic. What we're going to do is solve to a certain extent, then later we continue with calculus, so that with the knowledge of calculus you can now employ that here, because I told you from the beginning that this class is assumed to be for absolute beginners, so everybody can be carried along. So here we look at the first one. Remember in the previous class we said that this sign denotes what? Laplace. So Laplace of a function t is equal to what? The integral from 0 to infinity of e raised to the power minus st f of t dt. This is what it gives us. So now if we look at this and say if f of t is equal to 1, what are we going to have? This is the first scenario for elementary function. This is the first scenario. So say f of t is equal to 1, I have Laplace transform of what? Instead of f of t now I have 1 is equal to what? Integral of 0 to infinity of e raised to the power minus st, where f of t is 1, we have dt. Now this will give me what? That I will use a definitive integral. So you say from 0 to infinity of integral of e raised to the power minus st means I will differentiate this here. When I differentiate it, I have minus s. That's why I say we are going to treat differential and integration, differentiation and integration under calculus later, so that everybody will be carried along. So when I differentiate this, I have it as a denominator. Differentiate minus st with respect to t, I will have what? Minus s. Then this will be remaining up here as minus e raised to the power minus st. Now because this is definite integral, this is equal to e raised to the power minus st, e raised to the power minus st. I bring out my 1 over minus s here of what? Of from 0 to infinity. Now with this we are now going to get the values of infinity and 0. We have it as equal to, have it as 1 over minus s e raised to the power minus, instead of my t now I have minus s infinity minus e raised to the power minus s of what? Times 0. So this is times 0 here, and this gives you, we do what? We assume the assumptions to be taken in. Assume that e raised to the power minus s infinity is equals to 0 or approximately 0. So with this I have that what? Please take note of this thing here. I'm going to explain it again why I'm using this assumption. So we have 1 over minus s, if this is equals to 0, I have what? Open bracket 0 minus e raised to the power minus this is what? That is e raised to the power minus s times 0 is what? 0. It gives you 0 minus 1, and this is equals to what? At the end I'm having equals to 1 over minus s times minus 1, which is equals to 1 over s. Therefore the Laplace transform of 1 is equal to what? 1 over s. This is it. The Laplace transform of 1 equals to 1 over s. I'm going to explain this for those that don't understand me. If I have, let me say I have 2 raised to the power minus 2 2 raised to the power minus 2 is equal to 1 over 4. But if the numbers begin to increase, like this is to infinity, as it begins to increase, you have, like let's say 2 raised to the power minus 3 will give you what? 1 over 8. 2 raised to the power minus 10 gives you what? 1 over 1024. Now you see that this value here is going to give me 0.25. This value is going to give me 0.125. As we are tending towards the higher number, tending towards infinity, it will be approaching 0. You can see this is getting closer to 0. This one now will give me 0.00. You can understand numbers like that. So in that case, it will mean that as the number tends to infinity in the negative, it is assumed to what? You approximate to what? 0. You approximate to what? 0. Now that is why we say assume that this is equal to 0. So I've explained this to you, and let us have a short break while we prepare for the other Laplace transform of elementary functions we are going to be treating today. There are many two we are going to treat today. So thank you very much for watching. Welcome back. Now for the other one, we say if f of t equal to k, if f of t here is equal to k, you have that this is equal to f of t equals to this is k, and therefore f of t is k here, f of t is no longer existing, so we have it as equal to integral of what? 0 to infinity raised to the power minus st, and we have k dt. Remember that k dt is the same as k k times 1. Therefore say that but k equals to k times 1. If k is equal to k times 1, we have that the integral the Laplace of k in this case is equals to the Laplace of k times the Laplace of what? 1. Right? And what is the Laplace of 1 initially? We have that the Laplace of 1 we call Laplace of 1 is equal to what? 1 over s. Therefore, we have k to be the constant. K is coming out. Laplace k times 1 equals to k Laplace 1. This is equals to what? K over s. So we have Laplace of k equals to what? K over s. Now let's look at the last but not the least for today before we look at calculus. Because when we look at calculus, that way we're going to come back to Laplace again. So we have that if f of t equals to e raised to the power what? A t. E raised to the power a t. If this is the case, we are having, recall that Laplace of f of t equals to what? Integral of 0 to infinity of e raised to the power minus st and what? F of t dt. Now because of that, I'm going to what? I'm going to replace this now. I have Laplace of e raised to the power at equals to integral of what? 0 to infinity minus st times e raised to the power at dt. Are we together? Now look here, we have that in multiplying here, the powers are going to add by the law of indices under the what? Product law. So we have that Laplace of e raised to the power at equals to integral of 0 to infinity of e raised to the power minus st plus at dt. I factor out t here. I have e raised to the power what? Minus s plus a t and what? dt of my integral 0 to infinity. Now this is giving me what? It's going to, when I integrate this, remember with the knowledge of what we did in integration of, in Laplace of 1, we saw something like this. So we are going to differentiate the power. differentiating this power now with respect to t, we're having minus s plus a. So you have minus s plus a in the denominator, and this value is just coming here. E raised to the power minus s plus a t. We have integrated it like this. So we have 0 to what? Infinity. Now this is the denominator. We can actually bring it out. I have what? 1 over minus s plus a, and what? E raised to the power what? Minus s plus a t. Now this is what? 1 over a minus s minus s plus a is the same as a minus s. So I can say that I'm introducing now, I'm going to introduce my infinity and what? 0. When I put the infinity here, the same assumption we used for that first one, where we say e raised to the power minus s t, since the t is replacing there now, so we have this to be what? We should have as what? We have it as what? 0. So we have 0 minus 1. The same thing that happened in the previous example we had. So we are going to have this now to be, we're going to be having it as 1 over a minus s of minus what? 1. And that is equal to 1 over s minus a. So we can say that the Laplace of e raised to the power a t equals to 1 over s minus a. So this is the what? This is the point, so we are going to call it in a. So we are done with our calculus class. So we are done with class on calculus. We come back to Laplace transform. Thank you very much for watching. Please share, subscribe, and also help us to comment on this video. It will go a long way to help us. Please, we would like to see you in our next video. Thank you very much for watching. God bless you.